Hello everyone, welcome back, and today we are going to look at the basic router configuration on a Cisco packet tracer. So the topology is the diagram you can see here. This is the topology we are going to set up, and the IP addressing plan is as from the table given there. These are the IP addresses that we are going to configure on our PCs and on our routers. So in our lab scenario here, learning objectives, upon the completion of this lab, cable a network according to the topology, erase the startup configuration and reload the router to the default state, perform basic configuration tasks on the router, configure and activate Ethernet interfaces, test and verify configurations, reflect upon and document the network implementation. Scenario: in this lab activity, you will create a network that is similar to the one shown in the topology diagram. Begin by cabling the network as shown in the topology diagram. You will then perform the initial router configurations required for connectivity. Use the IP addresses that are provided in the topology diagram to apply an addressing scheme to the network devices. When the network configuration is complete, examine the routing tables to verify the network is operating properly. So that's the lab requirement. So we have got two routers and one switch which is going to act as the bridge. Then we have got three PCs. You can see here the routers are connected through the serial ports, and the router 2 here is connected to the PC through a copper crossover. So we go to our packet tracer. We're going to pick our devices here. So we pick this router of 1841. Pick another router again. Then we pick a switch. Then with the two PCs. We are now going to connect, we are now going to cable the interfaces from our topology here. So the router and the switch are connected through fast Ethernet 0. Then router and the other PCs connect through fast Ethernet 0 over crossover cable. Now we go to our connection. Use a serial. From this router, we use fast Ethernet 0. I connect to fast Ethernet number 1. Then fast Ethernet number 2, connect to that PC. When you come to this interface, this router here, you see now it doesn't have a serial port. So, but we have been told that this router and the other router should be connected through a serial port. So what we do, we come to that our router. We come to the physical view. We are in the physical port. So we come here to WIC2T. In the WIC2T, make sure first of all you power off your router here. Power it off. Then you move this module up. So you move this module. So you see, after you've moved that module, you are now going to power it on. You're being told that the device is still booting. Please wait until it is finished. Okay. So while that one is booting, let's also do the same to this other router here. We come to WIC, power it off, and now bring that module, then power it on. Let's go back to this our switch number 1, and now see. We now see it has now fast Ethernet 0 and 1, and also serial 00 and serial 001. What about this? This other also the same. The serial ports have been added. So we're going to connect to those two serial ports. We are told here The port is used serial DCE. So we come to this serial DC here. This one is serial DCE, this one is serial DTE. So we are supposed to use serial DCE. Then we connect. Then lastly, the router number 2 here connects to PC number 1 through a copper crossover. So copper crossover here. So connect first Ethernet 0 to that. And let's see what the topology gives us. The topology says that this network is .1, .2, .0. Then the interface of router number 1 here is .1. This one is also .1. Then when you get to router number 2 serial, this will be .1. Then .2, .1, .2. So you just give it a note here. That is 192.168.1.0/24. This one is 192.168.2.0/24. Then this one will be 192.168.3.0/24. While this PC will be on .10, this interface here will be on .1, .1. This one also will be .2. Then this interface will be .1. Come here to the move. So that's it. Now, what we do, we are going now to give the interfaces the IP addresses. So we are told that switch 1 here will use the IP address of .10.1.10. Will be 192.168.1.10/24, and its gateway will be .1 here, and this PC's gateway will be 3.1. So we come to our router here. First, before we go to our router, let's give this PC IP address. So it is 192.168.1.10. Gateway will be 192.168.1.1. So either you can configure your router from the CLI, or you just come to CLI and you will do your configuration. Or while you are on the config tab here, you just go to the interfaces, you go to interface serial 0, here. When you click it, it brings you the interfaces. Now here you are supposed to give it IP address. So IP address will be 192.1.1. That's subnet mask. Then you power it on. When you power it on and you come down here, you see here the configuration. IP addresses have been configured, and also it has told you no shutdown, so means that the interface is now up. Also come to this first Ethernet, this first Ethernet number 0. So first Ethernet 0. Sorry, this one was supposed to be 2.1. Sorry. On that serial interface, you're supposed to give it dot 2.1, not the 1.1, so that IP address don't conflict. Then you go to first Ethernet 0, give it IP address of 192.168.1.1, that subnet mask. Then you turn that interface on. You see here, after you turn it on, it tells you no shutdown. Then you come to this other router here. You go to serial 0. Serial 0, IP address of 192.168.2.2, that mask. Then you turn it on. You see no shutdown, so meaning that that interface has come up. So the interface has changed the state to up. So even if you look at it, you can see now the interface has now changed from red to now green, means that it is up. Then we come also to this first Ethernet 0 here, and also turn it on. First Ethernet 0, you give it IP address of 192.168.3.1, vulgar mask of that one. Then you power it on. You see it's up. Now it is up. Okay, let's also give this PC an IP address. So the IP address of that PC will be 192.168.3.10. Its gateway will be 192.168.3.1. Let's see now if this PC can reach that gateway, its gateway. So ping 192.168.3.1. It's able to reach the gateway successful. And can it reach the network of 192.2.2? It can also reach that the address of that interface that is on this router or the other that face that network, because when the packet is sent to this router, the router will be able to know the destination where that packet is, because it will find that one in its routing table. It will find that network of 192.163 in its routing table. What about if we ping .2.1? It's not able to go through because it doesn't know about that specific port number, port address. So there is where we now, I think, we implement the IP routing. So while you are on this switch, we are going to implement routing. So we are going to implement static routes. So on this switch, we are going to tell it the network where this network belongs. With its gateway will be 192.168.2.2. This 1.2 here. So you come to that router there. Then you go to static. While on static, give it a network of 192.168 dot 3.0. That's the network where the PC belongs. Then the wildcard, not the wildcard mask, the subnet mask of 255.255.255.0. The next hop will be 192. That is on that second router, 192.168 dot 2.2. You add. When you add, you see it comes here. So the more you add, if you need to add another route, a static route, you also come again, clear this one and add it. You see it will be added here. Also, when you come down here, it's the same. If you are on the CLI, you will have type IP route 192. That's the network, and the mask also the next hop. It's just the same with the same configuration, but here we just go direct and in a very simple way. So also make sure it is bidirectional. So while you are also on this router, you need to tell it the network of 192.168.1.0. So come to a static and tell it the network of 192.168.1.0. The mask is 255.255.255.0. My gateway here will be 192.168 dot 2.1. So you see, while you're on this router, we want to reach this network. We'll tell it the gateway will be 192.168.1. So let's see if we can, from this PC, we are able to ping that network of 192.3.1. So ping 192.168.3.1. So you see it's now able to reach, meaning that the route is now working. When this PC here send the packet to this router here, it will get to the router. Then the router will look at this routing table and find, do I have the route to that network? Then it forwards to the next hop. Then when they get to the next hop now will deliver the package to it, the final the destination. So let's see and see our messages. We are seeing how our packet is traveling. We are pinging the network of 3.1. So let's see if it gets to that point. The router will verify and send it back. You see, it has been verified as a positive. Now let's try something here. It turns positive. So also while you are on this PC1 here, now we are able to ping 192.168.2.1. Initially, before we configured the route, before we configured the static route, we see here while we tried to ping 192.168.2.1, it failed because the time we were told that the request time was out. Now, but this time when we try to ping, it's able to ping. Now, can it ping the network of 192.168.1? Let's try to see that. Or while we are on this PC, let's see if we can ping the other PC. So I'm going to try to see if we can ping that other PC. So ping 192.168.3.10, and let's see, descending the packet. Let's see what will happen when it gets to PC number 1. It has reached PC number 1. Now the packet has to travel back, and when it travels back and it is verified as a positive, then means that the ping service went on successfully. You can see here it's a tick here, meaning that the packet was able to reach PC number 2 successfully, meaning that PC number 0 here is able to communicate with the PC number 1 here. Also, while on PC number 1, is that communication by direction. Let's see if you can ping PC 0. So PC 0 is on a network of, so ping 192.168.1.10 and see if we'll be able to reach that. So it has sent the packet is traveling. When it gets to the router look at the routing table to check the destination and the next hop, then it forwards to the next hop. After it reaches the last router, the last router will forward it directly to the destination. The packet is sent back. It gets to the router looks at the routing table and forwards to the next hop. When it gets to the last router look at his routing table and look at the final destination, then forward it to the final destination. You see here, it is a positive feedback. You see, that's now how we implement routing. This is a static route. So in our next lab, you will also be able to configure OSPF. So this is the network that we are to implement on the basic routing. I hope you understand it, and if you don't understand anything, just feel free to ask me in the comment section. I'll be able to reach to you immediately. So thank you, and let's meet in our next video tutorial.